We have our next speaker from Aerotronics, Lucas. Go ahead.
All right. Well, we'll try to make up a little bit of the time. I'm going to talk today about what is the real domain of sUAS, or drones, which my previous speaker didn't think it was a good term for it, but everybody in the world knows it as drones. We've tried all kinds of terms, but well, if you Google the word drone, gets you much better results than Airpass or sUAS. There's a lot of discussion going on these days about UAVs, their future role, and how they best can cohabitate with what is already in the skies. So I'm going to talk a little bit about how drones should operate together with the other vehicles that are in the same space. Just a little introduction about Aerotronics. I won't bother you too much with it, but we're a company that designs, makes and manufactures VTOL systems. Well, we're in the back. We make multi-rotor systems, and we sell them worldwide. We currently have over 250 of these systems flying every day by our customers. And we work with a team of 35 people. And in our job, we come in contact with a lot of regulators worldwide. And they all bump into the same questions. How are we going to integrate these systems into airspace with the rest of the systems that are currently operating in this environment? Well, numbers you have seen in all the slides. It's very nice. It's going good with the UAV industry, so we're happy. But what are the sUAS best at? Well, you see a couple of applications, and during the last 2 days, you already heard people talking about all kinds of operations like search and rescue, inspection, agriculture, of course, very huge, mapping, well, and for security force like police, crowd management, etc. But most of these systems are operating in the domain below 500 feet. And I took this text from the FAA. This 500 feet barrier, you know, is considered generally as, you know, the limit, well, the height that helicopters normally should fly when they're not landing or taking off. And above congested areas, it's even 1,000 feet, you know, also to don't make a lot of noise. And our systems, the small sUAS systems, the small UAS systems, most of the times they operate below this 500-foot limit. So why are we trying to, you know, regulate these systems the same way as we do with aircrafts? Because most of the times they don't even, you know, get into the area where other systems are operating. Well, of course, there are a lot of, well, solutions proposed. You know, we've heard about the transponders, and you have, of course, a lot of sensors on board, you know, to try to mitigate risks and let the systems not bump into other systems. But what does that have as a complication? Well, it creates a different challenge because, like my previous colleague said, like Marco said, now it's okay if you have 2 of these systems fitted with transponders in New Zealand, but it will be a complete nightmare when all the small systems, you know, and there are a lot around at the moment, will be fitted with transponders. It will be a nightmare for air traffic control. You know, it will be like a Christmas tree lighting up, and another aircraft, you know, cannot tell the difference between something that's actually in their space and is not. So, and apart from that, most of these transponders are big. I know there are some smaller transponders at the market right now, but most of the times they're also expensive. Well, if your transponder is more expensive than the aircraft itself, you know, it's not proportional and it's not needed, we think. So most UAVs are equipped with types of sensors to mitigate risk. We of course have the acoustic sensors. We have these optical flow sensors. Stereo vision is a very small one, put the coin next to it. It's done by TU Delft. And we have now technology radar on chip. So you can fit already the systems with a lot of sensors to try and avoid collision with objects or with other vehicles. But only with these sensors, we don't think it will be enough. There needs to be, and this is something that is commonly known, if you share information between different systems in an intelligent network, you can even get a better, you can even more mitigate risks. So a sensor network where systems are communicating with each other, with emergency services, even with traffic lights. Well, so what we have thought, we, together with chip manufacturer NXP, who is heavily involved in ITS, Intelligent Transport Systems, car-to-car communication or car-to-X communication, because it's also cars to infrastructure communication. We are looking to see if we can use the same technology, which is now, you know, becoming widely available within, you know, it's put in all the intelligent cars, because it will be a low-cost solution, which actually fits perfectly in the domain that we are operating, because we are interconnecting with the infrastructure that's low to the ground and with other users of this below 500 feet area. So I'll show you a clip about what ITS is and what it is doing for the car industry at the moment, and then I will continue on how this can work for the SUAS industry as well. Show you a little clip.
Dedicated short-range communications combines high-reliability wireless communications and GPS, allowing cars to talk to each other and to roadside infrastructure such as traffic lights. This gives cars a 360-degree awareness of nearby vehicles, even in situations where the driver cannot see them. Using vehicle position and speed information received from nearby cars, an onboard computer can warn the driver of hazardous situations, such as a vehicle running a red light or failing to give way. This helps avoid intersection collisions, which are responsible for 60% of multi-vehicle crashes. The technology can also help prevent level crossing accidents. The system can alert drivers of a car braking ahead, even when the driver's vision is blocked by other cars or trucks. The system can also alert drivers to approaching emergency vehicles. Infrastructure-to-vehicle communications can warn drivers of roadworks and temporary reduced speed limits, for example in school zones. Real-time notification of roadworks, breakdowns and congestion help drivers to select alternate routes.
That is actual footage of BMW, where you see an accident not occurring because of this technology. Well, this is an overview of different systems communicating with each other. And well, what we are trying to show is that with ITS, you know, it already has a worldwide participation. You have ITS, 3 different standards. You have the standard in the US, in Europe, and in Australia, or in Japan. But they all use the same technology if it comes to antennas behind it. They're using the 802.11p standard. Because of course it's like a Wi-Fi based communication standard. But the good thing about this standard is they had to find a way of using this Wi-Fi technology for fast-moving vehicles and for longer distances than your regular Wi-Fi. So with a lot of development, with the push from the car industry, they came to this definition, this 802.11p. And well, for most of the small unmanned systems, this again suits it very well. It's an already defined standard. You know, all the big companies, all the big players, car manufacturers, chip manufacturers, Cisco is involved in this project as well. They all contributed to this standard. And the problem is with trying to come up with something new, like I heard the guys from NASA talk yesterday about, you know, it's why should we go for something new if there's already something that a lot of people agree on? And you can not only communicate between vehicles, but also to structures. To give you a little more insight in the channels used, you see that you have a dedicated channel to collision avoidance, the collision avoidance safety channel. You have channels for emergency services. So that means if an emergency vehicle comes, you know, all the cars will then move aside so they can let the vehicle through. And the protocol has been very well defined. This is what is already here. So this is the protocol they're using at the moment. And the good thing is they have left space for other, well, it's called Car2X, to other systems to be part of this whole structure. So what we want to do is want to reach out to the whole industry and together work on a platform to make this standard available for our systems. Because if we can achieve something like this, we can safely operate these systems even when they are, you know, flying thousands in a city. You can safely operate these systems without without fitting them all with the transponders, which is a very bad idea. And instead of fitting all sUAS with transponders, you now only have to fit the emergency helicopters or the emergency service systems with one of these, well, Car2X or Drone2X ITS systems. So when a helicopter comes in at low altitude, below the 500 feet, it warns all the systems that are in the area to divert or even to land. And that's a much more cost-effective way than do it the other way around. So we set up the Drone2X user group, and well, this is very fresh, and we start to invite different manufacturers from all over the world to take part in this program, so we can find a good solution for systems to cooperate in the same space. All right, thank you for your attention. No questions? Well, we just registered drone2x.com, so we will put it online probably very soon. So yeah, because drone is the word, Marco. It's a much easier to use. Yeah.
You know it has negative connotations? Predator and reaper. They have negative connotations.
Yeah.
Drone does not have a negative connotation in this context. Even the people that are against drones, if you talk about humanitarian uses for drones, feeding a hungry world, you know, anti-deforestation efforts, anti-poaching efforts, people do not mind drones. The drones they don't like are the drones that are killing people's kids. The drones they don't like are the people that are used to assassinate people in other countries. It's bullshit. The drones are not the problem. It's Predator, Reaper, and General Atomics.
Okay.
Oh, wow.
That's what you really think. I don't think that. I know that.
Okay.
That's the problem. I go over here and talk to these people in Berkeley. I have my own focus group right over there. It will never work to promote killing people's children. It's not going to work.
Hi, I'm Michael DuBroy from Swift Radio Planes. The problem I see with this is like ADSB. This is a cooperative solution. We can't do ADSB for avoidance because it's a cooperative solution. There are non-participatory aircraft who never have to join, and it's very trivial to spoof this aircraft. And how is ITS any different? We require everybody else would now have to adopt to ITS and join in. and it seems to me to be very, A, easy for me to join it, and we use this in ISM band in cities, these crowded environments. This is a very active bandwidth that has very high power signals on it anyway.
Sorry, what kind of band do you want to use? I didn't get the whole question.
You were on 5.8 gigahertz, and that's a very active bandwidth already.
Yeah, no, but okay, the FCC in the US has defined these bands exactly for this purpose, for this car-to-car communication.
It's also Wi-Fi in 802.11ac.
No, yep. What they did with this, in different countries it's different frequencies, but what they did, they put much wider space between the different channels to prevent, I can give you, afterwards I will give you some documentation about this, but they really thought about this. It's not, and they really tested it in large quantities, to see what the interference will be. Cisco and NXP put a lot of money in a company that designed, specifically this protocol to withstand, all the influences and all the interferences from different systems. So trust me that trust them, that these frequencies are good and guarded and will not be.
Trust the frequency part more. I'm just curious how you handle cooperative aircraft. How do you make a ballooner join in on this program?
A balloon?
How do you make a hot air balloon join? They don't have to do ADS-B. It's their grandfather.
Okay.
How do we change
that?
But
I'm looking more into, okay, but hot air balloons, most of the times they go, during startup and landing, you can control what I didn't show yet is that the different areas that you want to guard, like the start and landing spots, you can fit with these transmitters as well to keep the systems out of this area when the landing or takeoff zone is hot.
But they don't have landing or takeoff zones.
What? No, but hot air balloons. Yeah, okay, but how? It's the same thing with low flying in agriculture fields with the small planes, that spray these fields. But you have to look at it in general. Also with the system for cars, there probably will be cars that are not fitted with this system. It takes time for all the systems to come up to this standard. And hot air balloons, you're trying to look with some exceptions. You're trying to make your point. But if you look in congested areas, if you look in the city of San Francisco, do you see any hot air balloons?
This is why, though, the FAA won't accept ADS-B. They've made it very clear that it is a grandfathered exception, that they don't intend to change it.
That's not really true.
No, and yesterday I had a lengthy conversation with Jim from the FAA, and they're very interested in a solution like this because they know transponders are not the answer to their problem.
All right, I'll talk to you later.
Okay.
Thank you, sir. The ADS-B conversation is something else. ADS-B, too, there's two things with ADS-B. Here in the United States, the AOPA did not really support ADS-B, 1. And 2, the FAA is talking about not supporting a public algorithm for ADS-B, which would mean you would have to accept the liability for that. The only companies that will be able to afford something like that will be like Northrop Grumman or Boeing. But anyway, we're going to move on to our next speaker, Joshua France from Regal. Please welcome Joshua. There's a clicker right there, and then there's a laser if you need a pointer, and then that's the clicker.